So now we're going to look at a quadratic equation in this form. Y equals a times the quantity x minus h squared plus k. The advantage of this form is that it's easy to graph the associated parabola from this form. It's easy to find the vertex, and it's easy, it's easy to find the vertex in this form. This is the form you would get if you completed the square on the form that we had on the previous video, which was y equals ax squared plus bx plus c. Now there's a little bit of confusion with sometimes with the terminology, what these two different forms are called, and for fairly obvious reasons. So the y equals ax squared plus bx plus c that we saw in the previous video, that's called the standard form for a polynomial of degree 2. This is called the standard form for a quadratic. Now, a quadratic is a polynomial of degree 2, so it sounds like you're contradicting yourself with calling the same thing two different things. But it's the you have to keep track of what you're talking about. Are you talking about the polynomial just as a polynomial? Then the standard form is what we had before. If you're talking about if they say standard form of the quadratic, they mean this form here. Personally, I would call it the form where you completed the square, but that's too many words, I guess. So you do have to keep that straight. I apologize if that causes any confusion. So this is the standard form for a quadratic. I guess the idea is that if you're thinking of it as a quadratic, maybe you're thinking of graphing the parabola. Okay, so the first thing is you want to know where the vertex of the parabola associated to this quadratic is. And this form is nice because we can read off the vertex pretty easily. So if you set the stuff inside the square equal to 0, you get x minus h equals 0. And you solve that, you'll get x equals h. H is the first coordinate of the vertex. And x equals h is actually the equation of the axis of symmetry. Okay, now the second coordinate just comes from the k at the end, the plus k at the end. The second. Now, remember, k can be positive or negative. So if it was minus 2 at the end of that equation, the second coordinate would be negative 2, for example. So that's the vertex. If you do the first vertex this way, as I said, you won't get the sign wrong. And that's the most common mistake people make, is they get the sign of the first coordinate wrong. They get it backwards. So this tells us how the graph of the function y equals a squared has been shifted to make the graph of y equals a times x minus h squared plus k. So what we have here is just a shift of the basic quadratic y equals ax squared. And so y equals ax squared, the whole graph has been shifted left by the absolute value of h if h is less than 0. So for example, if h is negative 3, the graph has been shifted to the left by 3, not left negative 3. The negative gives you the left, and then you have to say how far to the left, which is 3, okay? Or it's been shifted to the right by h if h is positive. So if h is 5, then the whole graph has been shifted to the right by 5. Notice that if you shift it to the left by 3 or to the right by 5, the vertex is also shifted from the origin left by 3 or right by 5, right? So whatever the shifting is, the same thing happens to the vertex. The vertex of y equals ax squared is initially at the origin, so that's why that number tells you where the vertex is going to be as far as left, right. And then we talk about up and down. So the graph of y equals ax squared has been shifted down by the absolute value of k if k is negative. So for example, if k is negative 2, then the graph has been shifted down 2. Okay? Or it's been shifted up by k if k is positive. So if k is 5, then the graph of y equals ax squared has been shifted up by 5 to get the graph of y equals a times the quantity x minus h squared plus k. It's a lot of words to say out loud. So the axis of symmetry is this equation that you got when you set the inside of this stuff equal to 0. So it's x equals h. That's the equation of a vertical line that goes through the vertex. X equals h, and it's called the axis of symmetry. And you will be asked for that, so you need to know that. So I have 2 examples. The first one's easier. The second one is on the next video. It's more complicated. So this first one says graph f of x equals 2 times the quantity x plus 3 squared, the quantity squared minus 1, and describe how this graph has been shifted or translated from the graph of g of x equals 2x squared, and then give the axis of symmetry. So you'll be asked questions like this, and so you have to answer it kind of like that 1 through 4 up above, well, with one of those. Okay, so first I'm just going to find where the vertex is. So I take x plus 3 here, x plus 3. I set it equal to 0 and solve, and I get x equals negative 3. I put a box around it because it did ask for the axis of symmetry, and that's the equation for the axis of symmetry. Axis of symmetry is not negative 3. It's the equation of a vertical line. It's the equation x equals negative 3. That's a vertical line. Okay, in the plane. We're talking in the Euclidean plane here, or the real plane if you want. So that's the axis of symmetry. That also tells me that the first coordinate of the vertex is the number negative 3. Then the second coordinate is just negative 1 because of the negative 1 here. It just goes there. Okay, so this means that the graph has been shifted from the graph of g of x equals 2x squared. It's been shifted left 3 and down 1. It's that simple, okay? Left 3, down 1. As long as you get the vertex right, you should get that part. As long as you don't psych yourself out, I guess. So left 3 and down 1. So I'm graphing it just to show you. So the vertex is at negative 3, negative 1. Just practice graphing. That's the axis of symmetry. To find 2 other points on the graph, you just go right 1 and up 2 because of the 2 here. Right, it's positive, so you go up. So right 1, up 2, and then left 1, up 2. And then you just draw the parabola in there. So that's just for practice. It didn't, I don't think it said, oh, it did say to graph it. So that was the first thing. It said graph blah, blah, blah. And so I didn't do it in the order it asked. I had to find the vertex and the axis of symmetry first, and then I could graph it.